Hi, everyone, and welcome. My name is Ricky Chang, and I'm your host for Easy AP Computer Science 8 tutorial. Did you know that there's a website that lists every Lego piece released by popularity? The most popular pieces are small and interchangeable. The bigger pieces are often variations of the smaller piece combined in different ways or have specialized purpose. The larger pieces are easier to use and help you build faster. In the earlier episode, we covered the foundational building blocks of Java language: variables, literals, operators, expressions, statements, etc. They are like tiny Lego pieces, but it's not practical or even possible to do everything yourself. That's why Java's designer offer math and system classes. They extend the Java capability without extending the Java language while helping you write programs faster. We will discuss the required methods for APCSA and a few useful methods from these two important classes. We will generalize how methods, classes, and packages are used to make Java more useful. I will try to consistently use method as the terminology. It is the preferred term for Java. I might slip up and use the word function. Don't worry, it means the exact same thing. A little bit about me. I started programming in high school on my own, and it was love from the start. I have worked in the industry for 30 years as a software engineer, as a product manager at great companies like Microsoft and Google. I wish I had a programming class and video to help me back then. Today, I want to help busy students like yourself to get excited about programming and, of course, get top scores in your APCSA exam. System class and methods enable your program to interact with the computing environment that it's running on. A long time ago, all computers had for input and output were letters typed on the keyboard and a screen that showed 80 by 20 letters. Today, even though the computing environment has advanced greatly since, Java assumes the same basic computing environment from the 80s. That's why system.out only display letters line by line. System.out method starts from the current ready-to-display position, then print all the characters supplied within the parentheses. System.out.println method does the exact same thing with the additional functionality of moving the ready-to-print cursor to the start of the next line. System.in_read is used to collect letters typed by the user. It's a low-level function. You should use it with Java util.scanner class. Knowledge of system.in and how to interact with the user is not required for APCSA. However, I recommend you learn about it. It will be useful when you want to make programs that takes direction from the user. We demo both print methods at the start of episode 2. See the link to explore more. Math class enable you to do all the common numerical operations that you'll find in a scientific calculator, such as exponent, trigonometry functions, etc. We will focus on the top 4 methods which are required by APCSA and a few useful extra. Abs method will find the absolute value of an integer or double value. Unfortunately, Java cannot help you find your abs. You'll have to work on that one on your own. You can also calculate the absolute value using the conditional operator. The conditional operator is the only operator that takes 3 operands. The operator tests the condition before the question mark to see if it is true or false. When the condition is true, then it evaluates the expression before the colon. When the expression is false, it evaluates the expression after the colon. In this example, we check if the x is greater or equal to 0. In case of true, it evaluates to x. Otherwise, you use the unitary minus operator to flip the negative number to a positive number and return that. Abs method and the conditional operator do the exact same thing. However, the method approach is much easier to understand, especially when you want to do additional compound expressions. Math.pow is the exponent method. It returns the base raised to the exponent power. 2 to the third power is 2 times 2 times 2. 4 to the fifth power is 4 times 4, 5 times. You can use the asterisk character as the multiplication operators. Using the POW method is easy. In case of 4 to the fifth power, you write Math.pow, open paren, 4.0, comma, 5.0, close paren. The POW method is more capable than how it looks initially. You can use a decimal or a negative number as the second parameter. The math class also provides the SQRT method. It's short for square root. A quick refresher. The square root is the value when multiplied by itself equals the original value. Mathematically, the square root could either be a positive or negative number. However, the square root method will always return the positive square root. The first challenge for you all. Suppose you're not allowed to use the square root method. How can you do the same thing using the Math.pow method? If you know the answer, put it in the comment section below. I will read every comment and give you feedback on your solution. Give it a try. The last required method is the random method. It does not take any input, and it gives you a random number somewhere between a 0 inclusive or less than 1. The smallest possible value will be 0, and the largest value will be 0.999 with a few more nines. There's a secret to the random method. It does not generate a real random number. It generates what computer science folks call a pseudo-random number. Pseudo means pretend, fake. In this case, deceptively similar. You can explore in the link below to learn more. For all practical purpose in APCSA, a pseudo number is more than good enough. A random decimal number might not be useful by itself. For example, if you want to pick a lottery number between 1 and 70, or select a card from a deck of 52 cards. A decimal random number needs to be converted to an integer value between a certain range. I will give you the steps. You subtract the maximum from the minimal inclusive value and add 1 to get the range. Then you generate a random number, multiply by the range, and cast the result to an integer. Cast will truncate any decimal results. Then you add the minimal value back. If you need a random number between 100 and 200, this shift ensures the smallest number generated is 100. So remember this formula. You'll definitely need it for your AP exam. There will be some variation of this question where you need to take the decimal random number and convert it into an integer range. It might even be more complex where you need the range and have two fixed decimal places as part of the random number. For the rest of the slides, I will talk about them quickly because they're not required for CSA, but still useful to learn. When you're given two numbers and you need to pick the larger one, use the max method. And use the min method to pick the smaller one. Another group of method is converting a decimal number to an integer number. If you want the smallest integer that's equal or larger than the decimal value, use the ceiling method. The floor method will return the largest integer value that is less or equal to the given decimal number. Think of them as rooms in a vertical number line, and you're moving the elevator up or down. You're already familiar with the round method. You use it all the time. When a grocery store item is priced at $3.99, you will round the price to the nearest dollar. Math.round does the same thing. Time for another quiz. Math.round is very close, but it's not the same as the method you learned in school. My quick research doesn't show the historical reason for this difference. Let me be clear. It's not a problem with Java. It's working as documented correctly. It's confusing if you unintentionally encounter the difference. For quiz number 2, do a little bit of research and figure out what's the difference between the rounding provided by Java versus the one you learned in school. Once you figure out the difference, can you write a conditional operator that performs the rounding you learned in school in the comments below? Let's zoom out. You have seen a lot of class methods. Let's talk about methods more precisely. A method is an action or behavior related to the class. The math class can perform many type of actions. Each action has a defined behavior to calculate absolute value, exponent, generate random numbers, etc. Imagine we have a class called Witch. She is our friendly neighborhood witch. She has a menu of magical potions that she can make. Our two most popular requested potions are the potion and the Repel potion. Based on the name alone, you can easily guess the purpose of each potion. Give her the name of the magical action and the ingredients. She'll whip it up in an instant and deliver you the magic item. You don't need to concern yourself about how the magic happens. The thing that you need to get right is the name of the magic and the correct ingredients in the correct order. If you don't have the right ingredients, things might even blow up, also known as runtime exceptions. In our silly example, she doesn't care if you accidentally give her dust mites instead of pixel dust for charm potions. She only checks the number of items provided. The first part of the name indicates the method's purpose. The full name is the combination of class name dot method name. The second part is the parameters. There are the input ingredients for the correct data type in order. Finally, there is only one return type that indicates the result of the magical brew. Sometimes the magical effect is dispersed into the world. Then void is used as the return type. All three combined together forms the method's unique signature, like your sign name. Method signature enable Java to guarantee that even a very big program with hundreds of classes and thousands of methods, they'll always find the correct method. Let's examine the math methods in detail. All the math methods have the static keyword, which means the method belongs to the class itself and available for all. The static keyword allows you to call the method using the class name dot method name. When a method doesn't have the static keyword, then you have to do additional extra steps to create an instance of the class before using the methods. We'll talk more about class versus class instance in future episodes. You can easily call math class because they have the static keyword. Random method doesn't take any parameters and it returns a double value. There are two versions of the abs method. One that takes an integer input and returns an integer output. The other one is for the double combination. Even though the two methods have the exact same name, however, because the full method signature are unique based on the parameters and the return type, Java can automatically find the best match. POW method takes two doubles. You get the pattern. Java allows hundreds of parameters, but it's considered bad practice to use too many. Lastly, the print method has void as its return type. Since the print method effects are quote-unquote dispersed into the computing environment outside the program detail, void is used as the return type. Let's keep zooming out. There are many classes from Java. So many, in fact, that it's difficult to keep track of them all. To solve that problem, Java used packages to organize a collection of related class together. Think about a toy factory. Inside this toy factory, there are many robot arms. Each robot arm can only make one type of toy based on the template it has been given. The template might be a ball or a bat. When activated, the robot makes just that one toy. A package is like that factory with a collection of robot arms. A class is the individual robot arms that makes one kind of toy. A package name will help identify the organization that created it and its primary purpose. System and math class belong to a special package called java.lang. Based on the name, you can tell it's from the makers of Java and is part of the language. Java.lang is also a special package because it's always automatically included. As you can see from this slide, objects, strings, integers, and double as other classes that are available. These are other important classes in the java.lang package that we will save for future episodes. Zooming out even farther at 1,000 feet, a big company may have many factories to make many things. Same for Java. Java provides many other packages. We will learn about java.util and java.io packages and the important classes inside those packages in future episodes. In this programming exercise, I asked Gemini to create a demo of the math class generating two random numbers and call commonly used methods. I want you to pause this video, type the bit.ly URL, land on this page, paste the code into your programming environment, then practice computational thinking using the debugger and walk through the code line by line. Let me give you a quick demo. First, let's set a breakpoint. We generate the first random number, step. So the class now printed out the two random number I generated. So the first random number is a positive number with 50. The second random number is negative 59.8. In the next part, I printed pi. It is a final field in the math class. I will save the discussion on final fields in the future. For now, just remember that math, a built-in PI, just like your calculator. I will run the rest of the program and point out some unexpected results. Here, you see a NaN. NaN stands for not a number. APCSA will not test you on any code that generates a NaN. But when you write program, you might unintentionally generate this value as I have shown here. It will be a good exercise for you to think about how NaN are created and how to fix it. Finally, you can use Gemini like a teaching assistant and ask it to generate more coding examples for you to study and explore the topic of math class methods. I showed you the top 10 Lego pieces, big and small. The key takeaway of this episode is that Java, the language, provides the foundational building blocks. Java, by using packages, classes, and methods, will offer you a huge collection of additional building blocks. We explored just two classes for numerical computation and displaying letters to the users. We will explore many more useful packages and classes in future episodes. Preview for the next episode. Text manipulation will be a huge part of APCSA. We will use the string class from the java.lang package to learn how to manipulate text. We will also use string to explore the difference between class and class instance. Finally, we will revisit the difference between a primitive and a reference data type. Please like, subscribe, and most importantly, give us the gift of your feedback in the comment section below. Your feedback and encouragement will help this community grow and better serve other busy students like yourself. Thank you for listening.